Three, two, one. Okay. All right. So this is coding Minimax using in coding Connect 4 using Minimax. So, um, and this is for some beginners. Like it can be a little bit intermediate. So when we want to code Connect 4, the first thing we can start with is the class Connect, and we'll get to Minimax later. But the first thing we want to do is code the Connect 4. So we can start with Connect or um, Connect 4 if you guys want to do that. And we can initialize, what we can do is we can initialize a few variables like self dot person equal to, and we'll set the puck for um, the person and the AI. So what I'm gonna do is self dot AI equals to, we just set that as just empty strings for now, and we're gonna initialize the board equal to that, and one, two, three, four. Okay, one, two, three, four. I'm gonna set the width of the connect forward thing to connect forward board to 6. Um, and then I'm gonna duplicate it. So let's copy, and the height is gonna be set to 6 too. So I don't know why it does that. So just copy 3, 4, 5, 6. So we have set the board, and I'm gonna get the person.ai. You can set this to whatever you want it to, or you can set that person to whatever you want it to. But just make sure we're gonna use these these strings or SCI SCI strings later in the video. So just make sure you keep it consistent. I'm also gonna put these in the description. I'm also gonna put these in the description below in case you want to use it. And now that we have the puck, the person, the AI, and the board, we are going to first display the. You're gonna. We need a way to display the board so it's more playable. So we're gonna define a function called display where we use self. We add self to it, and then what I'm gonna. Sorry, excuse me. What I'm gonna do is I'm gonna for loop the board, and I'm gonna print the line x. I'm gonna print each um I'll print each line, each list. I'm gonna separate them using this long L thing. So at the bottom, I'm just gonna do connect 4. Sorry. Um, game equals to connect connect 4, and then game dot display, which is should display the board. When I run it, it should display the board. But this is kind of not looking the way I want it to. So, and like there is a the thing is there's these strings here aren't visible on this side. So what I'm gonna do is I'm gonna end it with using the built-in function with this, and I'm gonna do slash n, give it some space. So um also I'm gonna put I need to print the numbers at the top so we know where we can put each puck into. So print join, and second, just gonna remove that one. So I'm just gonna create a list of 0. It's a more efficient way to do this, but um, uh, I don't know. You can use for loop, but it's kind of gone with this. So I'm just gonna copy what I have here. So that should have been a list. So 0, 1, 2, 3, 4, 5. You can also for loop it, but yeah, and then use dot end equal to space. That will get your results, but um, up to you. So now that we run it, you can see 0, 1, 2, 3, 4, 5, and it's aligned with the stuff. And the end here is also been put on. So now that that's done, we need to be able to um oh yeah, we need a function that allows us to place our pucks. But before all that, we need yeah, we will need a function that allows us to place the pucks. We can start with that one. So I'm gonna create a function named place puck. So which takes in self the position, which the position could be 0, 1, 2, 3, 4, 5, and also the person. So is it an AI or is it the actual person? So um and then and I'll show you my thought process here. So for Y position, just like um up and down. So for loops the board. So it'll go for Y position in reverse, range length of self dot board, which basically all it does is it reverses the for loop. It just goes from the length of the self dot board and then just keeps going up, 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 up. And this is pretty much what it does essentially. Just give me a second here. Okay, so that's pretty much all it does here. You can do if self dot board by position and then position, which will basically equals to space self dot board by position, and then This should have been exposition, but this variable should have been named, could have been named exposition, but it's up to the person to, or I can just, or you can just change this to exposition. So is equal to person. And break. If you can hear a loud fan over there, that's my laptop. So sorry about that. Um, so okay, this is my thought process. So what this essentially does, it will, yeah, reverse for loop. You basically come here, check if this one is empty, which it does here. So if self.board.exposition at the bottom is equal to nothing, or empty string for space, which is here, it will basically just drop and put it all the way at the bottom. So it would just set the thing to the person. The person could either be, has basically has two options: self.person or self.ai. So just basically drop either one of these two and then set it to that. So now that we've done that, we need to find a way um, to make sure that like this, when it drops, doesn't just like replace it with like another one. So if this one drops first, now I want to drop a second one. Let's say this one, it doesn't just replace this one. So what we're gonna do is we're gonna create another if. We're gonna create an elif statement. Elif self.board y position and x position is not equal to, so it's not equal to the space or empty, is y position, and it's equal to 1. So what this will do is that it will go all the way. So if this one is filled, it will just go up and then add one to it. And that's pretty much it. So now that that's done, we need to make a way, or find a way for it to like make it work. So what we're gonna do is we're gonna create another function which we can play as ourself, pretty much. So the we create a function named game, or sorry, play. Add self to it. Make sure we always add self, and we can just do while sorry while x is equal to, it's not equal to, less than 5. Um, we, we need to create a, oh sorry, why is this equal to 5? Self dot display play. Oh, yeah, you can set x to 0, or this is just to like place 5 pucks. Input. We can also, ignoring this for a while, we can create a person input. But let's just do this one for now. So input equals to int input um put puck. So I'm gonna put the puck in. Hopefully you guys can see this. I don't know how big it can get. Um, okay, place puck, blah blah blah. And once we've placed the puck, I want to place oh, I want to add the function place puck. Position is going to be input, and person, second one here, is going to be self dot person. So now that we have that, we can just dot play. Now we have that, we can just play. Cannot access local variable info word. This one should with a value. Right. Oh, sorry, other way around. PT. Sorry, actually, other way around. It's what's wrong with this? Give me a second. Sorry about that. We can just name this Puck. Sorry, Puck. And then this one has to be input, and you can just play Puck. It's gonna change after a while. So we'll just run the function and then put Puck. Let's say one. It should put the Puck in like that. And let's say we want to put another one. It should put on top, and uh, yeah. So yeah, we forgot to add the uh, this thing, but it's fine. So now that that's working, we can. What we need to do is find a way to make sure. We need to find a way to make sure all the function. Make sure we can check if we win or not. So what we're gonna do is gonna make a function named win check or whatever function you want. But I kind of like this one. So win check. And what this function is going to do is going to take one parameter. So self and player. This takes in one parameter named player. So and in Connect 4, there are four. Yeah, there are just four possible ways to win. So you can win horizontally, vertically, horizontally, diagonally in a positive slope, or diagonally in a negative slope. So I'm gonna do horizontal. So the horizontal check. The easiest way to do this is just a for loop for row and range. Wait a second. So we're gonna. I'm sorry. Oh fuck. So we're just gonna copy. So sorry, I forgot where I left off. So this is the horizontal one, which is just like checks for the row, column, and just checks the column for one, two, three. Just so one, two, three. Which is kind of odd. I should have changed these. This one checks for the vertical, which is basically just the row plus one plus two plus three. There's a diagonal with the positive slope. It goes like this: y plus mx plus b, and just checks for the. I haven't changed this one yet, so we're gonna change the code over here. It's gonna be a one, two, three. plus 1 plus 2 and plus 3. It basically changes it. And we're gonna do the diagonal again for the negative slope. I think it's probably negative y plus mx plus b. Correct me if I'm wrong in the comments. Yeah, and also make sure to change this one to a 3. Yeah, so make sure to change that one to a 3 because of the just to make sure it's checked. And this one is going to be changed to from 3 to 6 for the row. And what we're going to do here is we're going to, since it's a diagonal, which goes like this, so this, um, we are going to turn the column to a negative, and that is pretty much it. So what it basically just does, it checks if, is there a win for this player, for a player, for whether me or the AI, is there a win? Yes, if it's any of these, it will return true, or else it will return, and that's pretty much it. So, and that's the win check, and we can run it again. So we can do self.place puck if win. Oh, sorry. If self.win check is equal to self.person, which is a string, if it returns true, it will print win, and then it'll just break. So we can just try this right now. So I'm gonna do the vertical one. So 1, 1, 1, 1. You win. And again, 0, 1, 2, 3. You win. Yeah. The diagonal ones, they work. Trust me, bro. Okay. And yeah, now that that's done, we can add a few more things. Like, for example, that's done. We pretty much got like a um, working Connect 4 board. That's not everything's done, and we can go into the aspect of um, mini of AI. So when I start with AI, I want to start with map out random. Sorry. I want to start with random. Okay, and the reason why I want to do that is because I just want to show you the difference between like I want to like kind of set everything up using random. So we're just gonna call this we're gonna create a function called dumb machine self, and then we're gonna use self.placePuck random dot randit. I'm gonna range 0 to 5, and then we're gonna do person self dot AI since it's a bot. Okay, so now we're gonna create a system in which we also need to create a person function. So person move, which basically just check this should return the move. Give me a second. Okay, so this should create the move. They also want to check for like any invalid moves or like moves that aren't really allowed. Like let's say I input a string, I don't want it to crash. So we're gonna use while true, which basically it's supposed to just hold like any. It basically just keep asking you if you do anything wrong, like input a number outside of the function, outside a outside like from 0 to 5, or string or anything like that. So try user input, oh, sorry, equals to int integer of input player. I'm gonna just do a player which column you you want to put do column um place puck. I just want to put I'm just gonna put place puck. Is puck. So this user input is basically just gonna hold all our stuff. Like so now that we've created that, we need to have a way to make sure we check like if a function or if what we put is valid. So I'm just gonna create a different function called is valid, which basically just takes in the user input. And what we're gonna check for two for we're gonna do is check for let's put self here. We're gonna check for if the board is outside or it's outside or inside the function. So outside or between or outside. Sorry, it's either if it's outside 0 or 5, then it's outside between the range of 0 and 5. Then return false. If it's inside, return true. So how we're gonna do that is we are gonna do if self.board and position is not equal to. Oh, sorry. And then we also have to check if it's filled up too. So that's very important. So if this is if column 0 is filled up to the brim, unless we put 0, we don't want it to just like overfill or just replace the one at the top here. What we want to do is we want to ask the player again, oh, this is filled up. Don't do this. So what we're gonna do is we're gonna put that one here. We basically just checks for it. Sorry, I'm gonna change this to user input. So the user input, or just checks for the overfill or position is less than 1 or sorry, that's equal to -1 or position we're going to just do less than 0 or position is greater than equal to 6. So, yep. And if it is, one of these things return false. If it isn't, I can just user input. Hmm, kind of messed up here. SER input, user input, return false, else return true. So, okay, and then we can do try blah blah blah. We can check if it's valid. If oh yeah, if self dot is valid, I don't know why it's not working. Okay. And then we put user input in. If self dot is valid, return the user input. If it's valid, return user input. If it isn't, oh, you're gonna have to redo it again. So ELLC else print invalid input. And or else we can do except print something went wrong. Or you can just do invalid input. So now that that's done, then the person move is working. So the return thing should cancel the should override the while true. So now that that's done, we want to kind of erase all this because it's kind of looking bad. I want to add the the dumb machine and then person move. So we're gonna use while loop. So while true, I'm gonna print the display self dot display um, person. So if you're unaware, I mean, I'm gonna talk about this later. Self dot player move. So we want the player to move. I'm gonna set a variable to that. So person input is the player move. Also, if you're unaware, self dot this is a variable and this is a function. Self dot person move. Set that. We set it as a variable. So those just said we set it as a variable. The return statement from here, the user input. And then we're gonna place the puck. That's already been checked as valid, so we're good. It's not gonna give us any error. So person input to the position x position right here, and then the person we're gonna do self dot person self dot person. So we're gonna use it if statements self dot incheck. Now we're gonna check if this plus person is one. So we're gonna put in the variable self dot person, or I forgot to have the self dot draw function because we don't even know if this win check doesn't even check if it's a draw. So self dot is underscore draw. Um, so give me a second here. We are going to add we're gonna add a draw function. Um, I'm gonna put it around underneath here, underneath the win check function. So define when check is draw. Sorry, function just draw self. Actually, not even need self. Um, so the draw function just basically just use for x in self dot board 0. It just checks if the board is full. So it just checks for the position 0, which is the top one. It just checks if it's full. So if all these are filled up, then oops, then it's draw. So if it's equal to so if x if x is equal to 1, 2, 3, 4, 5, 6, return false, else return true. Makes sense. We can check this out. 0, 0, 0. I'm just kind of wondering, maybe this actually doesn't work. Okay, I'm gonna save that, and I'm gonna do for game dot is for print printed. Apologies for this. Just want to make sure. Okay, now that that's work, I'm gonna go back on everything. Okay, now that that works and the draw function has been made, we are going to we're back to the win check here, the win check and the draw. So we're gonna display it. Display the board again. Display the board. Break. So if it's a win check, I don't want it to just like break and then not display the board. So if I place 3 of these, and I put the fourth one, I don't want it to just break instantly and not display the last the last state of the board. Like I don't want it to not display the last state of the board because I'm not going to be able to see whether I won or lost. So just to, and then we're gonna just print. Oh, sorry, we aren't gonna print anything. So now that that's done, we are going to self. We're gonna go to the bot we made, the dumb bot we made. So self dot display. Um, sorry, we're not gonna use that one yet. So we're just gonna use self dot dumb machine, and it called the self dot dumb machine, which just place a puck anywhere. I'm gonna check if self win check dot AI or self dot is draw, which is basically the same thing. For it, self dot display. Oh, you could either just copy all of this. Sorry, I just kind of realized that. Apologies, I'm just starting. Um, that's pretty much it. Or and okay, I'm just gonna put this here. So and so you just want to kind of put this here. Oh, apologies. So that's done. We can we need to find a way to tell us if we won or lost. So I'm just gonna put this here. Just the self dot win check and self dot stuff. So once the while loop is done, we can check it one more time, whether we won or lost. So if AI won, we lose, or draw, we still lose. And if we win, AI loses, we win. So um yeah, this is pretty much it to make some kind of bot. See, now it works. Two, and it's kind of placing anywhere. Three, still placing anywhere. Four, I win. So um and it'll work the other way around. So trust me. So now that that's done, we can move on to Minimax. It's gonna be hard to explain. So I suggest you um I can I suggest you watch a video on I'm just gonna pull up the video right now on Sebastian League. So this guy, gotta pull up the video. Pull up the video here. So pull up the video on this guy named Sebastian League. You can watch a video on him, but like if you already kind of know what it is, then kudos to you. I'm not really good at explaining that well, so I'll try my best. So let me just pull up this video right here. So what Minimax does is it just checks for all the possible states of a move. Let me skip to his video here. This is kind of the thing to describe it. In Minimax. So basically, what Minimax just does is that it will set different scores to different states. So if an AI wins, it'll basically just set it to a higher score than if I said I win. So where you get the minimax from is that um let me move this one. So where you get the minimax from is um so we can set this ones to mini max min max. So min max min max. So what it does is that it says different states to um, different scores to different states in the board. So the highest being where it wins. So how we're gonna do it is we can. It's gonna be really hard to explain. So just bear with me. Um, so max basically just picks the maximum, which goes here, and this one picks the minimum, and the max here too. This one picks the minimum, which is the person. The person wants to minimize, and the AI wants to maximize. So the person will pick three because it wants to minimize, and then you as the AI black, or sorry, not AI, not robot. Um, you as and the machine as the AI wants to maximize. So it will wants to oh sorry you as this is the uh holy Okay, back again from a cut. Trying to figure out how I was supposed to explain it to you guys. So you're far better. You're more better off. Um, Kind of just watching the video, or you can watch it from Kao Yang's video on Minimax. Um, so this is basically just the one way I can explain it to you guys. So it basically just sets different states to different board, sorry, different scores to different states of a board. So plus one being where plus so you're more likely to understand it better. I'm just give me a second. Okay, so back again. Jeez. So sorry. Here it says black is trying to minimize while white is trying to maximize. Basically, you can just think of it like one way that I try to think of it is like kind of like in Marvel's Avengers. It's you can think of it like Doctor Strange, seeing all the possible moves. So let's say this move is where this move at the bottom here, or this negative one here, is where Thanos snaps. This one is where Thanos doesn't snap and they win. What Doctor Strange is trying to do is will pick obviously pick the one where Thanos doesn't win, and I can do the future. Okay, so okay, now we're here. Now we're here. Um, sorry. This part is where Thanos snaps. This part is where they win. They Thanos doesn't snap, and none of them win. This part is where they capture Thanos, and let's say Thor just cuts his head off, like in the Final Avengers movie. Um, and this part is where basically none of them win. So um, obviously the two outcomes where we want to win is this one. So that's what Doctor Strange is gonna do. It's gonna pick this one. It's gonna pick um, the highest possibility of him winning. So it's either gonna pick 3 or 5. So it has those two options. Then Thanos. Now it's Thanos' turn. Um, Thanos obviously wants to win, so he's obviously gonna pick the 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 uh, the best chance for him to for them to lose. So he's gonna pick the lowest probability, and then it will go up here, and it's pretty much the same thing for the rest of these two. Um, so yeah, that's pretty much Minimax, and you can apply the same thing to this. So basically, just like checks for all the states of the board, and then picks the one where it's most likely to win. So, like I said, you're far better off watching a video about about it, like by this guy named Sebastian League. Explains it a lot better than I do. So, um, yeah. So I'm just gonna skip to back to the coding part. It's kind of hard to explain, so bear with me. I'm just gonna explain as I'm doing it, and I'm gonna reference his videos as I'm doing it. So to make it kind of easy for you guys to understand to some degree. So now that we have a machine that's working, we want to create a better machine. We don't like this dumb machine because like obviously it's dumb. So we want a better machine. So what we're gonna do is gonna create a smart machine. Use that function smart machine. And we're gonna call it self, and we are we're gonna set the best score to negative math by infinity. Yeah, we have to also import math. Don't forget to do that. Import. Okay. Okay, now that that's done, negative math by infinity, we can set the best move. The kind of requirements for your for the AI you're making. So you're gonna need a smart machine, which basically just plays the move. You're gonna need the minimax function, which is a recursive function, and but gets in by the tree is the recursive function. So yeah, um, so you're gonna need the smart machine minimax. You're gonna need to know all the possible moves. You need to know all the possible moves. So we're gonna create a function named possible moves. And that's pretty much the requirements. And you also need to be able to know that you're winning. So, like Doctor Strange wouldn't know if Doctor Strange didn't know all the possible moves. He's obviously not gonna be able to do anything. Okay, so um, so for the possible moves. Okay, so um, sorry about that. I just it took a pee for a second. So we're also gonna need one more function named undo. Oh, we're gonna need an undo puck. So these are kind of the four functions. So we need a smart machine, minimax, possible moves, and undo puck. So the easiest one to start with is the undo puck, which basically just for loops for y position in range length of boards. Also, guys, if you want to use if you're not really fun with classes, you can it also works without classes. You just gotta figure out how to do that yourself. So yeah, position. Also, if you just want to put 6 here, you can just put. This just checks for the length of the board. So you also need to take in the position too. Position, and we're gonna take in the position or the user input. You can change it. I can change it to user input for consistency because we do that for play Spark too. Send input. Oh, user input. User input. If user input is not equal to space, then self.board dot y position user input is equal to and basically snap out of existence, and then we can break it. So now that that's done, we can return to the. We can get the list of possible moves for the mini. Actually, no, we can skip that. I'll get to it when just so it's easier for you guys to understand. how to do it. So you have a best move and you have a math dot negative math dot infinity. The best score basically just is just gets the best score. Wait a second. So now that we have that, we can do for loop for move in self possible move, which just gets all the possible moves. And we're gonna do that right now. So I thought it was gonna take. I thought I was gonna spend a few minutes later, but looks like I have to spend it now. Just gets a list of all the possible moves. So list, set a list. Um, for x in range 6. If self board 0 and x equals to this. All this just checks is first to get on the list. All it just checks is if 0 is full, 0, 1, 2, 3, 4, 5 is full. If 0 is full, then it's just gonna get the list of 1, 2, 3, 4, 5. It's just gonna print the list of 1, 2, 3, 4, 5, which is the columns of the board. So if this one is full, then we can't really put any moves in there. We can't really make any moves out of it. So yeah, and and that's pretty much it. So if it's empty, then we're just gonna get the list of the rest. We're just gonna get the list of it. If it's full, then you're not gonna really do anything with it. So let's start append. Append the list of X. Then we're gonna return the list. And now that's done. Okay. Um, okay. Now we're gonna for loop the possible moves. I'm gonna for loop the possible move. We're gonna do self place puck in the possible move, and this won't be checked by the when check function. So we're gonna check for the possible move, and then we're gonna do a minimax. So it's gonna check all the. Now then we're gonna do a minimax. So basically self. We're gonna set the score to self dot minimax, and we're gonna set this to false and 0. For now, just like ignore these two parameters, and then we're gonna undo the puck. Self dot undo puck move, and if score script. Okay, now that we have done this, we're just gonna paste the puck self dot place puck to the best move. I don't know what happened there. Best move, and then self.ai. So now that that's done, I'm just gonna kind of explain to you what it does. So that's done. You can add comments to this if just like if you come back to it, you can kind of know what you're doing. So for moving possible moves, this just for loops all the possible moves. So it just checks for other possible moves. It will place the puck in the first move, which usually is going to be zero. Um, I don't really I- like. You can add a few more things to it if you want. If you don't want it to always place zero first, but this is just like the basics of Minimax. I'm not really trying to or like Connect Four. Like with Minimax, I'm not really trying to explain more or make it more complicated than it is. So I'm just gonna explain it to you. So this is self.placebuck in the first one. Check the score. It will set this variable score to minimax. Then it will undo itself. Minimax will just it's a recursive function. I'll come back to that later. If the best score is greater than the best score, so if the score from minimax is greater than not done infinity, then just set the best score to score and best move to move. So best score will be set to score, and then best move to move, and then we just place the puck once the for loop is done. So now that we've done that, we can work on the mini max. Yay! For some people, holy, this is actually gonna this might actually be hard to explain. So I'm just gonna copy this because I'm kind of running out of time here. I'll make this like easy. So I'll just explain this briefly. Self win check. Just I said these two different variables. So a score of the person. So if AI wins, return 100. If person wins, return -100. And if it's draw, return zero. Or if it's reached the maximum depth, return zero. And so um so return zero if it's draw or it reaches maximum depth. Oh yeah, we also haven't added the maximum depth yet. We can just set this to we can set it to just for efficiency standards. We can set it to uh, I don't know, 3, so it doesn't like branch out because the efficiency is O of um, B raised to power depth or something like that. Like the amount of spaces left in the board raised to power amount of possible moves raised to power the depth. So you can get really really inefficient really really quickly. So okay, are we? So now that we have that, we're going to add an if statement. If maximizing, that is if the um, that is if we're maximizing. So just what we want to do is we want to take the greatest value. So to do that, we are going to set a max variable name max evaluation. I'll explain it in reference to the Sebastian League's video. Some of the variables are changed. So just to kind of like explain, just so you can have some kind of familiarity. Can't really say that word today. Familiarity with it. So now we're gonna copy the smart machine. So we're just gonna copy it to here. I'm just gonna paste it here, and yeah, you can give her some get rid of the spaces. Kind of gets annoying really quick. Sorry, this taking too long. Um, you can watch this in 2x speed if you want to. So now that we've set the Minimax, we're gonna set we're gonna change this to depth plus one, and we're gonna set the move and then set the maximum eval to the maximum of max eval, and then score. And then we're gonna return the the max eval. Else I'm gonna explain the code later, like not right now, because I just want to get all this done. So we're gonna rename this to mean eval, and we have all that blah 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 false. We're gonna set this to true, and we're gonna set this to person because this is one is the person has to be minimizing. The person has to be minimizing. So we're placing the puck. Now we're trying to find and minimize. We're gonna call this one min eval. I'm gonna find the minimum of the min eval. We're gonna return the minimum eval. Okay. Um. That's pretty much done. So, um, like I said, it just assigns what Minimax does is assigns different states, different scores to like different moves on the board. So in reference to here, so since we're the first to play, I'll explain the code like from kind of like line to line. So the person plays. I'm sorry. Person person plays. Then the you can name this to smart machine. Then the smart machine plays. Then the smart machine plays. So just give me a second here. Just gonna move back a little bit. Yeah, but I've moved back a little bit. Backed up. So the smart machine plays. So it says the negative not the infinity best move. It for loops all the possible moves. So let's say this is a possible move. It will just for loop them, and then it will place the puck to the set move. Then it would use Minimax, which goes all the way here. If the person is one, so sorry, if I've one, or sorry, the AI is one, not AI. If the AI is one, it will set the score to 0 to 100. It set the score to 100. If the person's one, set the score to negative 100, which we don't want. And if it's draw, which we also don't want, we set the maximum or the maximum of that. If it reaches the maximum of that, it returns 0. So and like that means it hasn't found a score yet. So and that's usually when it plays um it plays it plays like the first move, like I said over here. So yes, and so if it doesn't, if it hasn't reached any of these, it's gonna check maximum. It's gonna do maximizing. It's gonna try to minimize. Um, just give me a second here. I'm trying to figure out. Okay, sorry. And so once it's done that, it's going to try to, like right here, the black is minimizing while the white is maximizing. So minimax false, and it's not maximizing. It's going to set the minimum evaluation to positive math at infinity. It's going to look for all the possible moves. It's going to follow all the possible moves just like it did here, which you can kind of see. Maybe you start to see some recursion, like starting here. So sorry. So here. So follow up all the possible move. And we'll place the puck in the possible move. Like you'll try to predict the person's move, and then we'll set minimax, which you can kind of see the recursion happening. Undo the puck, like undo the move that is done. Okay, go back and then set the minimum. So get the minimum eval of the score. So um, and they'll basically do the opposite for here. So we get the maximum of the score. Um, and you set the minimax here. It's true. While this one is false. And just in relation to this. Um, okay, so this is basically the same function, the minimax. So the if statement here just checks and sets the value to 100, negative 100, and 0. You can set this to pretty much whatever you want. I'm pretty sure you can set this to like negative math by infinity. Sorry, it's math by infinity, negative math by infinity, 0. Um, if maximizing player, set max eval to negative math by infinity. For loop, all the child in the position sets everything. It will place the puck, and then you place the puck, check minimax, which just checks it again, which checks the minimum eval, and then self dot it will undo itself, and then it will find the maximum of each one that's scored, and pretty much does the same for here. Pretty much the same thing. So now that that's done, we can run it. Hopefully it works. Hopefully, I know it's gonna work. So just set that one. Let's see. I want to win. It will block me. So you can see here, and not that's very good. That's very nice. But like, I want to show you something. So this one set to like 3. The max depth set to like 3, and this is where you can kind of set the hardness, the difficulty of the minimax of the AI.
No, bro, son, you can't move. Let me just.
Okay, this is where you can set the maximum, where you can set the difficulty of it. So I want to show you a problem with the minimax, like just minimax itself. So let's set this to 10, and I'm just gonna this okay, three. Okay, okay. I'm just gonna run this again by deleting kill terminal. Run again. 10. So I'm gonna place 1, and you're gonna see it's gonna take a long time just to work. And um, I'm pretty sure you can wait like about a minute, and it won't be done. This is because, and I think I explained it a little bit. This is because the maximum depth, the efficiency of it, I guess, is set to O of b raised to power d, where b is the branching factor, like the possible moves, and d is the depth. So if we set the the if the branching factor is 6, the depth is 10. So let's say the depth is 6. That will equal to I'm just gonna so 6 raised to power the depth is 10. So gonna be a big number. I'm just gonna use my calculator because this is actually taking a while. So 6 raised to power 10. That is 6,466,176 different calculations. That is way too much for this to calculate in a matter of seconds. And it just makes it really inefficient. So what we're gonna do is we're gonna kill this one obviously for for first, yeah. And then we are going to um, use some alpha beta pruning on it, which basically just like kills a bunch of possible moves that are going to happen. So like okay, so like it just kind of gets so we can just kill some possible moves and increase the efficiency. That's kind of the gist of it. Just all it does is increase efficiency. So like I said, you have to watch this guys or some other Minimax video on it to um understand this stuff. So I suggest you watch this, like I've been saying for a while. So I and I want to go back to this one and like you can set this at 3 and it'd be more efficient. And when we set this at 3, we only have 216 possible moves. Sorry, 216 calculations. So when we set this at 3, it's 216 calculations. And when we set this to the depth of 10, a depth of 10, we get 60 million. So you can see how that's like it gets it can get really it can take really long for your computer to like think and find the possible move. So um I mean unless you have like a very quantum computer or something like that, I'm not sure it's like really efficient to like use this kind of thing. So in alpha beta pruning, what it basically does is if you watch this guy's video from like here to here, you kind of understand it. I don't really see a reason why I should explain because you can just watch this guy's video. It basically just like cuts a few things off. So like just based on this guy's video, we can see here that we've gotten the number of 3, and we don't need to know the rest of these. We know that this was going to become -1, 2. We know we're going to pick something less than 2, less than or equal to 2. So that means we don't have to pick. We don't really need these ones. But my explanation isn't really that good. So I suggest you pick someone you watch the video. You can be seen multiple times. So I'm just gonna go into the code and um, do my best to explain. So in the minimax function, we're gonna add a two more parameters. We're gonna add the alpha and beta. Okay. Now that that's done, we are going to yeah, just gonna pass the alpha and beta over here. And basically, how we're gonna change this is we're going to set the beta equals to min val, and then score, and then if beta is less than equal to alpha. I'm not gonna save this yet. So I'm not gonna save this yet. I'm just gonna keep going. I wanna run this and get the. So the maximum depth here was, so when I place the puck, it's gonna take an awfully long time, and this was set to 10 at the start. So this is awfully gonna take a long time. I'm just gonna leave it here while it's running, and I am just gonna keep coding the alpha beta printing, which is gonna make it so much efficient, so much more efficient. So, and I'm not really sure how efficient it's supposed to be. You can do your research, but it kind of varies. So I'm gonna keep going. I'm gonna do the same for the minimizing one. So minimizing. So it just copies, gets the beta is greater than alpha, blah blah blah, and same thing. So we're also gonna put these ones, so we can set the alpha to negative mat dot infinity. Set this one to mat dot infinity. Okay, and there is no need to change anything else. Hey, and we've been coding for, I don't know, about 40 to 1 minute now, and it's still not done. It's probably not gonna get done enough anytime soon. So what I'm gonna do is I'm gonna just stop it because it's been going for so long. Right now, it's really not gonna matter. Like people are already gonna, like the player is already gonna lose interest. So now that I've saved it, and it has alpha beta pruning, that's pruning in it, which is gonna make it so much more efficient. We're gonna run this one more time, and I'm just gonna place a puck. Oh, um, oops. Sorry, give me a second. Alpha. I'm gonna set this one to alpha. Make sure to do that, which you're gonna get error. Beta, and boom. So this is gonna make it so much more efficient. But oh, what is it? Hmm. Line 118. Oh, sorry about that. Oh, I'm so sorry. Supposed to set alpha. This beta supposed to be here, while alpha is supposed to be max of that, and if beta is greater less than alpha, greater than it's equal to alpha break. Uh,
Bro,
for these two. So we set the score to 10, um, which without pruning takes a immensely long time. If we now that we have this, what we have to do is just, oh, second. So this is the max eval. You forget. You can fix the codes. Um, that's done. You can run the function, and it should place. Usually, with my computer, which is kind of like a potato computer, this would have taken a really long time. But with pruning, this should take not that long. I'm gonna place the puck here at number one, like I did before, and this should not take that long. See, it should have taken a lot of time, but now it's a little bit more efficient. So, and then now you can enjoy um, playing against the AI. So I'm gonna put the code in the description below on GitHub. If you want to follow me, please do. And thank you for watching my video. I'm just gonna play against the AI. Uh, just have some fun. You're not gonna win. But yeah, you might have to set the efficiency to like it's maybe like 9 or something or 8. I'm gonna set the efficiency to 8. I'm gonna press Command C here. It's like because like it's still kind of slow. So it's the 1, 2, 3. Block me. 2, 2. Oh, I lose. So sorry about that. Okay, that's done. Thank you for watching my video. Please subscribe and like if you like it, and I'll be posting more soon. Thank you.